right, this video today is going to walk you through section 2.8a, which is all about proportions. I'm going to just introduce you to the concept, show you two quick examples, and then when you get to class, we will practice them. So, a proportion is two ratios, which we've been talking about in this chapter. So, A to B and C to D, two ratios that are set equal to each other. So, these are going to have the same value. So, two ratios that are equal to each other. And you're going to be asked to solve for something that's missing within those ratios. And to do that, we're going to use something called cross multiplication, which I'm sure many of you remember from years past. So you're going to cross multiply to figure out a missing component of that proportion. So let me show you why that works. In a proportion, the two diagonals of the proportion should be equal to each other when you multiply them together. So A times D in that first diagonal is equal to whatever the multiplication of the other diagonal is, B times C. That's why cross multiplication works to solve proportions, because the two diagonals, when you multiply them together, are going to be equal. So I'm going to show you a first example of a proportion that's relatively simple. I'm going to actually skip number 1 and go straight to number 2. So I want to solve for x. So to do that, I'm going to take the two diagonals and multiply them together. So I'm going to write this one out long ways. You don't have to do this, but I want to show you what this looks like. 2x times 3 should be equal to 4 times 6. Now if you know what 2 times 3 is and what 4 times 6 is, you don't have to write this all out like this. I'm just showing that to you since we're just learning it. But essentially what you're going to get is 2x times 3 is 6x. And 4 times 6 is 24. Okay, those are my two diagonals. I've set them equal to each other because that's the rule for proportions. And I'm going to use my equation solving skills to figure out what x is equal to. So I'm going to divide both sides by 6. So x is equal to 4. Okay, and that's how you solve a proportion. So we take the two diagonals, set them equal to each other, and multiply. All right? So I'm going to show you one more quick example of one that's a little bit more challenging, and then we'll do the rest. I'm going to have you try them on your own here. So I'm going to go through, I think I'm going to go through number 4. So we'll leave number 3 alone for now, and let's talk about how number 4 looks different than the example we just did. This example has two expressions in it. So when you take the diagonals, we want to multiply this 2 by everything down here, not just the 2, not just the x, but everything. So what I would like you to do when you have an expression that looks kind of like this, I want you to put those right away before you do anything in parentheses to show that you're going to multiply the diagonal by everything that's in that expression. So let's take this first diagonal, 2 times x plus 2, and this is how that would look when you write it out. 2 times x plus 2 is equal to my other diagonal. So 11 times x minus 5. That's why those parentheses are really, really important to show, because now when you look at your equation, this is clear that I'm going to have to distribute to figure out my true equation. So when I distribute that 2 to everything, I get 2x plus 4 is equal to, I'm going to do the same thing over here, 11x minus 55. Okay, and now this is an equation that I remember how to solve from my last unit. Okay, I want to try to get those x's to one side. So I'd like you guys to finish off number 4. You guys know how to solve equations. That should be old news. And then when you come to class, we're going to talk about problem number 1 and problem number 3.